Let's now talk about Internet and NAT Gateway, because these two services here are the things that will enable your instances, your resources within your VPC to connect to and to receive connections from the Internet. So let's start with Internet Gateway. And what it does is it enables internet connectivity from resources with a public IPv4 or IPv6 address. It's horizontally scaled, it's redundant, and it's highly available within the VPC. That means if a certain availability zone goes down, for example, the Internet Gateway will still work, and other instances and other subnets outside of that availability zone will still have connectivity to and from the Internet. It is AWS managed, which means we do not need to worry about provisioning nor about managing it. It can be added as a target in route tables for traffic that should be internet routable, which means either being able to access the internet or, more importantly here in this case, to receive traffic from the internet. If our instances should not receive traffic from the internet, then we would not go with an Internet Gateway, then we would go with a NAT Gateway, as we will see in a few minutes. The subnets here are considered public if they are associated with a route table that has a rule with an Internet Gateway as a target. So if in any of the route tables, or rather if in the route table that the subnet is associated with, there is an entry to an Internet Gateway, then that subnet is considered a public subnet. Otherwise, if it has no rule with an Internet Gateway as a target, it is considered a private subnet. Route tables don't necessarily have to have a catch-all entry with an Internet Gateway as a target, so we can have, for example, narrower ranges. We can pass elastic IPs of EC2 instances outside of the VPC, or we can also pass IP ranges for non-AWS data centers. Let's imagine that we would like to go over the internet to an on-premises data center. We can also set only the specific IP range of that data center in our route table and then mark this as the Internet Gateway, or rather provide an Internet Gateway as the target. All right, so Internet Gateway also does the network address translation. Okay, so it's not because we have a NAT Gateway or a NAT instance that Internet Gateway doesn't do NAT. It also does network address translation, and what happens is that for outgoing requests, the Internet Gateway provides the one-to-one mapping from an instance's private IP address to its public address or to its public IP address, so that the outgoing traffic has the public IP address as the reply field. And then whenever we get the reply, then it does this reverse mapping to actually forward the reply to the correct EC2 instance. It's important for us to understand that the EC2 instances themselves, they are unaware of their public IP addresses. This is done by the Internet Gateway. And then for incoming requests, it provides the mapping between the public IP address and the correct private IP address of the target instance. So if we are querying a certain public IP address and this ends up in our Internet Gateway, then it's going to see, okay, to which instance or to which private IP address does this public IP address belong to, then it will forward the request accordingly. And there is also something like an egress only Internet Gateway. This is for instances with IPv6 addresses, and it prevents incoming connections. That's important because IPv6 are globally unique. That's different than IPv4. The IPv4 addresses are not globally unique. So if you define a VPC here with 10.0.0.0/16, there are probably thousands of other VPCs which have the same range, which means they would have similar IPs in their IP ranges, but because they're isolated from one another, and this is a private IP range, that is fine. But for IPv6 addresses, they are globally unique. I'm going a little bit too much into detail here, so let's talk about NAT Gateway. And what it does is it enables outgoing connectivity for resources in private subnets. Remember, private subnets are those that are not associated with an Internet Gateway. So the diagram here looks a little bit different, and what it happens is we deploy a NAT Gateway in a public subnet, and then the traffic that needs to access the internet from a private subnet goes via this NAT Gateway over through the Internet Gateway and then to the internet. The instances in the private subnet can connect to the internet, also to other VPCs and to on-premise resources, while preventing unsolicited external traffic from reaching the instance. Classic example is you have a bunch of databases here, and you want to make sure that they can reach out to the internet to download updates and patches, security stuff, but you want to prevent the internet from directly connecting to these instances. So this is a classic use case where you would enable outgoing connectivity via a NAT gateway, and you would prevent incoming connectivity because the private subnet has no direct association to the Internet gateway. The public IP address of the outgoing request will be that of the NAT instance, so it's going to be this one, and then the NAT instance or the NAT gateway is going to take care of this network address translation. Small remark here, the difference between a NAT gateway and a NAT instance is that the gateway is AWS managed, the instance we have to manage ourselves, and the instance is a little bit older, and I would not recommend using it. I would just go with the NAT gateway. There are two connectivity types. The first one is public connectivity type, so the instances in the private subnets can connect to the public internet. That's the most common use case, but and in this case there is an elastic IP assigned to it at creation time. And the second case is a private connectivity, when instances in private subnets can connect to other VPCs or to on-premise targets. Now, connecting to other VPCs, there are multiple ways of doing that. Same thing with the on-premise target. For example, for VPCs, we could talk about VPC peering, but it's also possible to do that via a NAT gateway. This is implemented within a single availability zone, at least the gateway, right, with redundancy. That means if the hardware rack within the availability zone where our NAT gateway is deployed, or where one of the instances of this NAT gateway is deployed, if it goes down, it's fine. It's with redundancy within the AZ. However, if the whole AZ is down, if this whole thing is down, then all the instances in private subnets that were relying on that AZ, on that NAT gateway, they will lose their connectivity to the internet. Right, that's exactly what I say here. So the best practice is to deploy one NAT gateway per availability zone to ensure high availability. Okay, so there's a difference between having multiple instances, that's the redundancy part, having multiple instances within the availability zone, and actually achieving high availability by deploying this NAT gateway in different availability zones. Of course, this costs more money, but it ensures that your instances in the private subnet can then fall back to this other NAT gateway instances here in case one of the availability zones is down. The costs here are per hour running and per gigabyte processed. So that means more instances are going to run for more hours in total. That means they will be more expensive. So it's a trade-off. Once again, depends on the criticality of the application, but it's just worth mentioning. Differently from the Internet gateway, which is highly available within our VPC, the NAT gateway is restricted to a single AZ. Just keep that in mind. Let's give it a try to see if we can then see how that works specifically here, or the steps that we need to deploy an Internet gateway and a NAT gateway. Actually, with the Internet gateway, we are already a bit familiar with it from previous demos. So let's create a new VPC here, and we're going to create just a VPC. If you would like to have a closer look into everything that's going to be created here and customize a few more things, you could say here VPC and more, and that would directly create availability zones for you. It would create route tables and a lot of other stuff. Internet gateway here, VPC endpoint. In this case, that is for the S3 VPC endpoint, but let's start with just a VPC, and that's going to be demo VPC Internet Gateway NAT. We will give the manual input here, so that's going to be 10.0.0/20 this time, a no CIDR block, and the names here. So that's just our simple VPC, and I just want to change a few things, try to understand how it works with a /20 instead of /16. That gives us, instead of 65,000, that gives us roughly 4,096 addresses that we have available to split across subnets. So let's go to our subnets. We're going to have one public subnet and one private subnet. We're going to create the VPC. We're going to select this VPC here, and the subnet 1 of 1 is going to be public subnet. And then we can also add another subnet here that's going to be the private subnet. Okay, and the availability zone, there is no preference here, but maybe we can just, for the sake of keeping things a little bit different, then we'll say 10.0.0.0/24, and once again it's going to block the last that's going to block the first 24 digits, or first 24 bits of this IP address, and it's going to free up the last 8. Now, that's fine like this. We could also have a /28, for example, but let's leave it like so. And then here we can create on EU Central 1B, and then we can also say 10.0.1.0/24. Important that this address here must be within the CIDR block of the VPC. If I were to say 254, for example, then this is not allowed because our VPC does not allow us to modify the first 4 bits of this part here because it's a /20. Okay, if I were to try to create here, then you will see that this tells us that the CIDR address is not within the CIDR address from the VPC. Now the CIDR address from the VPC is just going to be something. Maybe I could actually try to write it here, where it's going to be 10. So that is, now that's a good exercise. 0000, 10 should be 1010, I believe. And then we have .0, that's this one. Then we have .0, that's this one, .0, that's this one. Okay, this, of course, this is not an IPv4 CIDR block, but this is how it's going to be translated out behind the scenes to CIDR, and or rather to the bits, right, from the numbers, from the digits to the bits. And then here in our VPC we are saying that up to here these numbers are fixed, and afterwards these numbers can change. So the maximum that we can get here is really 1111, right? And this is to the power of 0, so that's 1 plus 2 plus 4 plus 8. So we don't have a lot of freedom here, or basically we cannot go any further than this. And basically that is why the .254 doesn't work. So if we do 10.0.1.0/24, that is fine. It's going to work, no problem. But just keep that in mind, that whenever you have a more strict CIDR block on the VPC side, then the CIDR blocks of our subnets must be within that CIDR block. Okay, so these are the two things. The name here is going to be private subnet and public subnet, and then once we create these two, then it's going to create them for us in the console, and we can then see them here. Now, I'm wondering whether there is any route table created by default, and this is probably associated directly with the route table from the VPC. This is created whenever the VPC is created, and if we click on subnet associations here under the route table, we will see that because there are some subnets without explicit association, they are then mentioned directly here. Let's then create a route table here that's going to be the public route table. And we'll create under this VPC, and that's it. That's all we need to do. It comes with a default route here to a local address resolution, which means this is private IP address resolution. So we have the public route table, and we can also create the private route table, right? So private route table, and we'll also create this in here. Perfect. So now under Internet Gateway, we need to create our Internet Gateway. We already have one Internet Gateway. This comes with the default VPC. Let's create another one. And this is going to be some demo IGW, for example. That's all. Now we need to attach this this Internet Gateway to our VPC. We can say here actions attached to VPC. We attach to this VPC here, and once we attach the Internet Gateway, then within our route table we should be able to edit our route table, edit our routes, and then add a new route here with a catch-all route. This means all of them, and simply please link to the Internet Gateway. Now we can save the changes, and that simply means that this is now a public route table. If we come to EC2 and we launch an instance here, let's just create an instance very quickly, and then launch instance. Let's take the Linux 2. That's going to be demo EC2 public. Right, and then let's take the EC2. That's fine. T2 micro, it's fine. That's free tier, so that's good. We can proceed without a key pair here, and in our security group, that's let's allow SSH traffic from anywhere. Okay, this will allow us to connect via the instance connect, I believe is the name. We'll just check that in a bit. This allows us to connect via the browser via AWS Console without having to download or create any key pair. Everything is managed by AWS. So everything else is fine, advanced details, and actually, no, not everything is fine. We need to edit the networking, right? So we don't want to deploy on the default one. We want to deploy on the demo VPC, and then we want to deploy in the public subnet. Now, when we deploy in the public subnet, we can also auto assign a public IP, and that is good for us. Here is demo security group, and we'll just say here as well, demo security group. And I believe that's it. So just SSH traffic, nothing more, nothing fancier. Let's launch the instance. This is within the free tier, so if you have a new account, that is fine. Within the first year, you should get 750 hours of EC2 T2 micro. And then we just need to wait a little bit here. If we click here and we don't see the connect yet. So let's just, there we go. And then we have this EC2 instance connect, right? You can see here that there is a public IP address, and then we can actually connect here. This is probably going to fail because it's too early. I think the instance is still creating. It's going to take some time. Yeah. So let's wait a little bit and let's see once the instance here comes and becomes healthy. So let's have a look. Initializing here, then we should be able to connect, right? So let's try once again. And I've been trying to connect to this for quite some time, and it's still not working, right? So let's do a little bit of debugging here. If we look under the instance connect, we can try to connect again. And I tried restarting the instance and it doesn't work and it doesn't work. And of course, then as it turns out, I just realized that we have created everything, but we didn't change the route table. We didn't change the association of our of our subnet with the route table. So if you come here to the VPC dashboard and we click on subnets, we have the public subnet, and then here under route table, you will see that this still has no route to the Internet Gateway, even though we have here in our public route table, we have the route to the Internet Gateway, right? So the problem here is that all we did is we just forgot to associate this with the subnet. So we can edit the subnet associations here. We can click on the public subnet and then we can save the associations. And now if you look under the subnet, then we will see the route table here. Now it does have the route to the Internet Gateway, right? This was the problem that was preventing me from connecting to the EC2, or rather to SSH, from SSHing into the EC2 via the console. So, or rather via EC2 instance connect. So let's try once again. Let's click on connect here, and then now hopefully that should work. Perfect. Very quickly, then we are here within our instance. Then we can, well, just due to the fact that we are here and we have SSH'd into the instance, that means it does have connectivity to the internet. But if we were to ping again google.com, it also has outgoing connectivity to the internet, right? So this is a basic thing for the Internet Gateway. What it does is, as soon as it is in a route table, it gives access to the internet to EC2 instances and other resources which are deployed within the subnet that has this association. Now let's have a look at the NAT Gateway, and I'm going to come back here to the VPC once again. But before that, let's create a new instance here. And now this instance is going to be demo EC2 private. And this once again is going to be an Amazon Linux. That's it, free tier, no problem, T2 micro. Key pair name, maybe here we could create a new key pair, and we can then just say demo EC2 private, like so. And let's create a key pair here. And network settings we will deploy again within this VPC, but now we're going to deploy this in the private subnet. It's not possible to, or rather, I mean, it doesn't make a difference, right? Because this is not going to have public connectivity to the internet. So we're going to leave it as it is, and we can create a new security group if we want to allow the traffic on port 22 for SSH. Let's just use the one that we have here demo security group that we have just created. This allows SSH, and we will see that even though we're going to create this, it's not going to have internet connectivity. So we can also click on enable here. We can enable the public IP. Let's see what is going to happen once we do that, and we'll see that that's not going to make any difference, right? Because the security group here, even though it allows the traffic on port 22, the private subnet that we have on our VPC dashboard, if we click here on our VPC dashboard, and then under subnets, and now let's fix this before we run into any problems. Let's change the route table association, and what we would like to do here is to associate this with the private route table. We're going to save this, and the private route table is just has the default route that comes with it, which is the local route. So now we should not be able to, I'm going to close this, we should not be able to connect to our instances or to the instance that is deployed here as a private instance, even though it does have a public IP address. If we were to try to connect to it, because the subnet has no association with Internet Gateway, that is not going to work. Perfect. So what happens here is the connection is just timing out. And now let's see whether we can actually enable outgoing access to the internet from this instance here by allowing or by creating a NAT gateway under our VPC dashboard. So under NAT gateways here, let's create a NAT gateway, and this is going to be demo NAT. The subnet, you can see that we can choose where we're going to deploy the NAT gateway. There has to be in a public subnet, so we're going to deploy in the public subnet we have created. The type of connectivity is public, and here we will allocate an elastic IP. Now this is very important here. We need to delete this afterwards, because if we do not delete the elastic IP and we just keep holding to this elastic IP and it's not allocated to any instance or to any resource on AWS, we'll pay for it. As long as it is allocated, we don't pay for it. But if we simply detach it from the instance and we keep this on our hands, we keep holding this address, then we are going to get billed for that. We don't want to do that. So let's now create the NAT gateway. And what we will do here is we will use this NAT gateway to edit the route table, or basically we will edit this route table here, and we will add an association to our NAT gateway. So now we're going to add a route to everything, and we'll simply say here we have a NAT gateway, and this is the NAT gateway that we want to associate to. Great. So all good. We have our private route table here, and let's just make sure that our private subnet is associated with this route table. That's the private route table. This is our NAT instance. This is our NAT gateway. No problem. Now let's come here to EC2 once again. This is our private EC2 instance. We cannot connect to it, but let's see if from within our other public EC2 instance we can at least ping the private EC2 instance. So we're not going to be able to just yet because the security group doesn't allow for that. So let's come here under our security group, demo security group, and let's edit the inbound rules. And we're going to add here a rule for all traffic, all ICMP, and it's going to be from anywhere. I'm going to save the rules. That's fine. And now we should be able to, by coming here in our instances on the public one, let's connect to it using EC2 Instance Connect. We should be able to ping the private EC2 instance. So here on EC2, let's have a look at the private one. If we were to take this public address, let's see if we can ping this public address. So try to ping this one, it just hangs out, right? It just times out because there is no route. This is not resolvable. Even though we have the public IP address, the instance is deployed in a private subnet, so there is no way for us to reach it with this public address. Now, if we were to use the private address, that's another thing. So if we were to say just ping with this private address, then you can see that we start getting some responses, right? So that means we can actually SSH into this instance here from our public instance. Good, so the ping command is working, it's no problem. But now how can we actually test whether this instance here has connectivity, outgoing connectivity to the internet? Not this instance, but the one that is deployed, the private EC2 instance. And for that here, let's go back to our EC2 instances, and we're going to launch a new one here because we need to SSH from our machine to upload the file for our EC2 private instance into another instance. It's called what is a Bastion host, I believe, and that is really not the best practice, but for testing purposes here, just for you to see that the instance will have the outgoing connectivity, that is one way for us to do that. So we'll just say demo Bastion EC2. This is going to be again Amazon Linux T2 micro. Let's create a new key pair. I'm just going to say demo EC2 Bastion, like so. And perfect network settings here. Let's change to our demo VPC public subnet. Let's auto assign an IP. Let's use an existing group. This is going to be our demo security group, and that's it. Let's launch the instance, and we need to wait a few seconds until it's up and running. So here, let's see now. Should be coming up anytime soon. Here I'm filtering for the state of running, so that's going to take a few seconds. Great. Now we can come here in the demo Bastion EC2 and we can have a look. When we try to connect to it, you see that we have the IP address here. Great. So let's try to now upload the file from our local machine to our Bastion host, right? So now what we want to do is to run the scp command, and here the file that we have for, or rather the key that we have is the Bastion key. This is what we will use to authenticate. And then we have the demo EC2. The private one is the one that we want to upload. And then here what we want is to have this IP, and we want to connect with EC2 user at this IP, and then we want to upload this to the home directory, right? So once we run that, then we can see that there is something happening. Once we click on connecting to this instance via the EC2 connect, then we will see that once the connection is there and we list what's in the home directory, then we get this demo EC2 private, right? So now here, let's change the mode here, ch mode 400 for demo EC2 private. And now let's try to connect to our private instance. So in our dashboard here, then let's have a look here. We have the demo EC2 instance, and the security group should allow us to have incoming traffic in the port 22. And now let's have a look at our private IP. So this is our private IP, and we will do here within our EC2 instance connect just the SSH-I demo EC2 private at EC2 user, and then at this private IP. Now this is going to connect to ask for yes. And perfectly here now you can see that we are inside our EC2 instance. Now this is another EC2 instance, and we are inside this via this Bastion host. And now if we were to ping here google.com, then you will see that we have outgoing connectivity. We can send ping commands, but we cannot receive connectivity from the outside world. So, okay, right. This was a lot of stuff. A lot of different things, different concepts here, but I just want to illustrate how the NAT gateway actually works. Important thing is, or rather maybe the summary here is where the NAT gateway is created. This is created in a public subnet, right? So within our VPC here, this is created within a public subnet. Let's go to our subnets, and then we can have a look at the public subnet route table. This is where we have the private subnet here, right? So this has association to the NAT gateway, but if we go to the NAT gateway, then you will see that this is deployed in our public subnet. So even though the NAT gateway is deployed in the public subnet, the association to this NAT gateway is done at the private subnet, because this is the subnet that we want to enable outgoing connectivity. And once we do that, then we can SSH into this via a private IP address. That's why we need this wrapper, like this Bastion EC2 instance deployed as well, so that we can then go via the private IP address. There is another way of doing that by using Systems Manager. But for that, we would have to set up VPC endpoints. It's a little bit more complicated, few concepts that I haven't covered yet, so just decided to go with the traditional way. I would not recommend using Bastion hosts everywhere. It should always be possible to find a better, more secure alternative, but for demonstration purposes, I think that's fine, right? So we come here, this one allows connectivity from the internet. We just come in via SSH, and then we come in and we SSH into our private instance via the private IP address, and then we verify that this instance has actually connectivity to the internet. It has outgoing but not incoming connectivity. Okay, so if your brain is still healthy, then I think that this is a good moment for us to pause and actually revert everything that we have done, and that's quite a few things that we have done. So let's come to EC2. And the first thing we're gonna do here, just gonna delete all our instances, and here let's actions, or rather instance state, terminate. Then in our elastic IPs, that's very important. The elastic IPs is not in the VPC part. It is in the EC2 part. Here you can see our elastic IP. Let's see if there is anything here showing for us. This is the elastic IP. We can release this elastic IP address, and this cannot be released, so we need to terminate the gateway, the NAT gateway before, right? So we need to disassociate this, and I'm getting some errors here. Let's have a look. No, that's fine. Okay, yeah, that's fine. So let's come here on the NAT gateways, then let's action. We will delete the NAT gateway. We're just gonna delete it. And let's have a look now. So I think this deletion should be quite fast. And once that is done, then I believe that we can go and we can release the IP address. Let's give it a couple of seconds. After a bit of time, let's try to refresh. It's still deleting, so it takes some time to delete. It's not as quickly as I expected. Let's see if we can already delete this IP address here. So let's release. No, not yet. It's still saying that there is this association, right? So now the status here is deleted. Maybe now we can actually release the IP address. And perfect. Now, once we do that, then there are no elastic IPs to be found here. Let's refresh this. We have a few security groups. We could delete them. If you want to leave them, that's also fine. They are free. Key pairs are free. Instances here, there are no running instances. That's the important one. And then under our VPCs, we can then delete our demo VPC IGW NAT. And here I believe that we first need to delete or remove this Internet gateway from our route table. Let's then delete these two route tables, but since they are associated with subnets, you see like everything is interconnected. Let's just release these here. So we have this route table, edit route table association, and then we can just get the main route table. We're gonna save this, and the same thing for this one. We wanna come here, route table, edit route table association, main route table, save once again. And now here in our route tables, we should have no explicit associations, and we can delete these route tables. That's good. Then we can delete the subnet. So now these route tables here, we can delete the subnets, and let's now try to delete this one and this one. Action, delete subnet, delete. That's no problem. Now the Internet gateway here, we also want to delete this. Actions, we want to delete this. Detach from the VPC, that's the first thing, and then we can delete it, right? Delete the Internet gateway, delete it, and now within our VPC, we can finally delete the VPC. So lots of stuff. There are a few things that will also be deleted for us. Security groups. So once we delete the VPC, we should also see some security groups decreasing here, right? Let's try to refresh, and then you see that we have just one security group afterwards. Anyway, so this was a quick overview of how you would on the console, right? How you would implement a NAT gateway and Internet gateway. As you can imagine, this is a nightmare to maintain if you have to click around and try to debug things by clicking things around. Best way would be to use an infrastructure as code tool, CloudFormation, Terraform, anyway, any tool that you would like to use. But these two, I think, are the by far the two most used ones for managing AWS resources. And there you can actually define all these associations in a declarative style. That's much easier to see. Also much easier to get an overview of your resources, to replicate them, and later on to delete them as well. That's actually what I am using to create temporary AWS accounts for these demonstrations, because then I don't need to blur this. I don't need to worry about access. I don't need to worry about exposing information, because after this video I just run one command and that destroys the whole infrastructure. Perfect. So that's it for today. Thanks a lot, and I'll see you in the next video. Bye bye.